Hello everyone, so today I'm going to be taking you through a Python tutorial. The goal of this tutorial is to get you up and running with Python and analyzing data in as little time as possible with as little background knowledge as possible. So it's going to be a very fast-paced tutorial, so you're definitely going to want to pay attention and you're going to want to focus in order to catch all the information. So the first thing you're going to want to do is we're going to download a software package for data analysis. So you want to go to www.anaconda.com. You want to go to Products, then you want to go to Individual Edition, Download, and then you want to select the appropriate download for your operating system. Okay, so go ahead and download that, then install it. So pause the video if you need to and get this software package. So once you've done that, you want to go into your search bar or whatever, open up Anaconda. I already have it open. And what you want to do is you want to go ahead and launch something called Jupyter Notebook. Okay. So we're going to launch Jupyter Notebook, and it's going to take you to a little file directory prompt like this. This is the file directory on your local machine. So I'm going to go over to Documents. You can go wherever you want, and I'm going to create a new notebook, and I'm going to click on Python 3. We're going to be creating a Python 3 notebook. So what Jupyter Notebook is, it is a data analysis coding environment, and it is basically built to showcase your code, showcase your results, and it's very commonly used in the field of research where people want to make sure that their results can be replicated with ease, and they want to demonstrate and share knowledge. So this is going to be something that you're going to be using a lot if you get into analyzing data. So the first thing you should notice is right here in this little drop-down menu, you can select the type of block that you're going to input. So we are going to select Markdown in this first block, and we're going to do a hashtag, and we're just going to type Python tutorial basics, whatever. Okay, so notice that in order to enter a block, you want to press Shift and then Enter, and that enters the code into the block. So now we're in a code block, and we can just go ahead and type our very first piece of code. So code, okay? So what we have just done here is we have typed print. A print statement just prints text out to an output console, and the output console is usually going to be below the code block if you're working in Jupyter Notebook. And we have passed a string to a print function, and it printed out the code. Now we're going to get comfortable with some arithmetic operations. So you can just use the arithmetic operations on your keyboard pretty much to make calculations of 5 plus 5, 5 minus 5, 5 times 3, Shift Enter to calculate, and then we can do 5 raised to a power. Okay. So that's the gist of our arithmetic operations. Now, additionally, what we can do is we can go ahead and use Boolean values. Okay, so you want to think about Boolean values as logical operators. So you have true, you have false, and then you have operations you can perform on Boolean values. So you can do true and true, which is going to output true. You can do true and false, which will output false. And the reason why is because the AND operator, it's a test, right? It's a test operator. And what AND is asking is it's asking the computer, is this statement true? And is this statement true? And if both statements are true, then the entire expression evaluates to false. Additionally, we can do false and false, and that'll evaluate to false. And now you can also use something called OR statements, and OR statements are a little bit less stringent than the AND statements. You can do true or false, and you only need one statement to be true for the expression to evaluate to true. So you can do Shift Enter, and there we have it, true. You can do false or false, and since nothing's true, it'll be false. And then you can do true or true, and you have 2 true values, so the expression will evaluate to true. So we've done printing text to a console, we've done arithmetic, we've done logical operators. Additionally, we can use other Boolean operators that work on numbers. So you can do 5 is less than 10, shift enter, that'll evaluate to true. 5 is greater than 10, that'll evaluate to false. 5 is less than or equal to 5. 5 is equal to 5. Okay. Now the next thing you can do is you can use another operator called not. Okay, so the not operator, all that it does is it just flips the value of a logical expression. So if you do not 5 is equal to 5, so 5 is equal to 5 evaluates true, and then not just means the opposite of whatever that evaluates to, and you do shift enter, false. Okay, so you've covered printing, you've covered arithmetic, and now you've covered logic. And the next thing we're going to be looking at is control flow. Okay, so we're going to make a little section, control flow. Okay, so if true, print here. Okay, so here just means that this block of code is being exited. Now another thing you want to notice is when you make a control flow statement, you're going to want a colon after the statement, and then you're also going to want to indent the block of code. So if we try to run this right now, it's going to say here. So what this is basically saying is if this expression is true, run this block of code. And now let's change the value to false and shift enter. And it doesn't run because this expression is false. Now you can replace the Boolean values with a logical expression. So if 5 is greater than 2, print here, and it's going to print here. Next, you have other ones. You have another operator called else if. So if 5 is greater than 2, print here. Else if 5 is less than 10, colon, print not here. Okay. So the reason why this did not get executed is because this statement evaluates true first, and this code gets executed. So because this evaluates to true, we execute this code, and we never actually make it here. So if we want to make it here, we're going to have to make this statement false, if 5 is less than 2. So now when we do shift enter, it's going to skip this block of code, and it's going to run this block of code here. Logic. And again, we can type else. Okay, so else just means that if all the logical statements above have not been satisfied, we want to run this. So just for fun, let's just make this false. Let's make this false, else, print here. Okay, here, there we go. So there's a control flow. So now we are going to get into problem solving and functions. Okay, so now what we're going to do is we're going to solve some problems using all the techniques, all the code that we have just gone over. So the first problem, so we can change it to Markdown, the first problem that we're going to do is even odd. Okay, so write a function that outputs whether a natural number is even or odd. Okay, so we can go and we can type in def, and what def is short for define, and that means we're defining a function. And then we're going to do the name of the function, which is even odd. And the function is just going to take in a parameter, okay, and we're just going to call the parameter n. And again, we're going to do a colon, just like we did for the control flow statements. This is a exciting little part of the tutorial because now you're going to learn a common coding technique that's used, and it's called recursion. So what recursion basically does is it solves a problem by converging upon a base case, okay? So if we're writing a recursive algorithm, the first thing you want to do is define a base case. And the base case is the most simple form of the problem where the solution is actually trivial. So we have to ask ourselves, what is the simplest number that we know without a doubt is even? Okay, what is the simplest number? And I'll give you some time to think about it. Shouldn't take you too long. If n is equal to, and what should that number be? So you could pause the video to think about it, or don't think about it because I'm just going to tell you it's 0. Okay, 0 is the smallest even number possible in the set of natural numbers. So if n is equal to 0, we are going to return true, meaning that the number that we have passed is even. Else, what do we want to do? So notice this return keyword right here. That just means we're telling the function to terminate, we're telling the function to stop running, and we're telling the function to give this value. Okay, we're telling it to send this, to send this value to output, or to output that value. Otherwise, we are going to return even, odd. Okay, we're going to return not even, odd on n minus 1. Okay, now you might be confused by this line. If you're a clever bloke, it might make sense to you. But if this doesn't make sense to you, that's perfectly fine. So we're going to do Shift Enter to declare the function to the memory. And now we're going to test if it works. So even odd of 0, right? That's true. Even odd of 1, false, because that's an odd number. Even odd of 2, true. Even odd of 100, true. Okay, even odd of 225, it's going to be false. Okay. Now you might be wondering, like, how the heck does this work? And this is the magic of what we call recursion. It is the function is calling itself again and again and again on smaller versions of the problem until it finally makes it back to the base case. So if you want to, we can go ahead and step through this function to see just how it works. So we know that if we pass in 0, it's just going to go and it's going to go to if n is equal to 0, that's going to be true, and then it's going to return true straight away. So let's look at the first non-trivial example, even odd of 1. Okay, and what does that evaluate to? Well, if we pass even odd of 1, it's going to go straight to this else statement, and it's going to evaluate to not even odd of 0, and even odd of 0 is true. Okay, so then it's going to evaluate to not true, which evaluates to false. And we can try another example. So even odd of 3. And now that we know how this function works, we can go a little faster. So it's going to keep running this block of code until we finally get to the base case and return true. So with 3, it would be not even odd of 2, which evaluates to not even odd of 1, which evaluates to not even odd of 0, which evaluates to not true, and then not true evaluates to false, not false evaluates to true, and then not true evaluates to false. And even odd of 3 is false, meaning that 3 is not an even number. So it basically flips the Boolean value back and forth until it converges upon 0. So neat little trick. So the next problem we are going to do, define a function that returns the factorial of a number. Okay, so we're going to pass this function a number. We're going to call it fact, so def fact, and it's going to take in a similar argument to last time, which is n. If you want to, go ahead and pause the video and try to solve this problem yourself using all the tools that we've just gone over. So we've learned this recursion, and to give you a hint, this problem is going to have a nearly identical pattern to this one. The only thing that's going to be really different is this line right here. And it's going to use multiplication, and it's going to use control flow like we've learned. So pause the video, give it a shot, and then if you can't figure it out, unpause it. If you can't figure it out after maybe like 15 minutes, unpause it and then continue, and I'll explain it to you. Okay, so we're going to use the same exact pattern that we used in the previous function. So if n is equal to 0. So what is factorial of 0? And in case you don't know this, it's actually 1. So factorial of 0 is 1. Else, you want to return n times fact of n minus 1. Okay? So that's just basically saying the factorial of n is equal to n times its previous number times its previous number times its previous number. Okay? So shift enter to declare it to memory, and then we can test it out. Fact of 5 is 120. Fact of 10. You can go try to test all these with a calculator if you want, but this is correct. So now this is actually a good time to learn about what's called iteration. So what is iteration? So I'm going to go ahead and just show you something real quick. So you want to type for I in range 1 to 10, colon, print I. So what is that? What is this doing? This is saying for every element I in the range of numbers from 1 to 10 up to 10, but not including 10, print I. Okay? So this is iterating through a range of numbers from 1 to 10. Okay? So using that, we are going to write an iterative factorial problem. Okay? So we're going to do deft fact of n. We can go call that fact1 so it doesn't overwrite this function. And then we're going to do out is equal to 1. So that's just saying that our output, the base value of our output is going to be 1. Then we're going to do for I in range of n plus 1, because we want to include n, okay? For I in range n plus 1, out is equal to out times I, okay? So we are multiplying out by I every time, and then we are setting the new value of out equal to the value of out times I, okay? So we're starting at 1, and then out is going to be equal to 1 times 1. Then it's going to be equal to we want to go ahead and put a 1 there, because this is going to tell the range to start at 1 and count up to n plus 1. Otherwise, what you'll see is that the range function will count from 0 to 1 by default. So if you do range 10, for I in range through 2, print I. Okay, if you do that, you'll see that it counts at 0, but we don't want it to count at 0. We want it to start counting at 1, since it's a factorial function. So it's going to do that. It's going to multiply out by the next element at every time. And then at the very end, so notice how I did a backspace. We're no longer writing code within the for loop. We're writing code outside of the for loop, but we're still writing code indented relative to the function. So it's going to be inside the function. And we're going to return out once the function terminates. And again, we can test our little function with a 5, should be 120. There we go. Fact of 0 evaluates to 1. So this is identical to this one. The only difference is that it solves the code entirely within one instance of the function, rather than having to call multiple instances of the function. And this method is more memory efficient. Okay, so when you use recursion, if you go back to our example here, the computer within the memory has something called a call stack. Okay, so what will generally happen is that when you do EvenOdd of 3, it's going to make another function call within, another function call within, all the way until it evaluates to the base case, and then it's going to circle back and then output the final value. But in the random access memory, while this is being executed, each function call is stored on what's called a call stack, which is a part of the computer's memory, and that takes up space. But in this case, the only thing really taking up space is this output variable that we defined, and in comparison, that's one integer, right? That's one element of space, right? That's constant space that we're using rather than variable space over here. Okay, so we've done factorials, we've done recursion, we've done a little bit of iteration, we have done some control flows, so we've done a lot of stuff. The next thing we are going to go over are what are called basic data structures, okay? So data structures. And the data structures we're going to go over are something called lists, tuples, and dictionaries, okay? Lists, tuples, and dictionaries. So let's go over a list, okay? So we can just call this list one. Okay, we're going to call it list one. And the way you define a list, an empty list anyhow, is by using these square brackets, okay? And that's an empty list. And we can define that. And we can do print list one, and it's just going to define, it's going to print out those empty brackets. We can also define a list with elements, okay? So we can do list one, 1, 2, 3. What's going on there? Oh, list one is equal to 1, 2, 3. And then you can just print list one. It's going to do that, okay? So this is all fair and well. We've, we know how to declare a list. We know how to print the list. We know how to declare a list with some elements. So we can also add an element to a list. So you can just do list one dot append, and then whatever element you want to add to it, okay? So then if we enter list one now, we've just added 5. And additionally, you can store elements of multiple data types. So if you want to add a string, you can do list one dot append and then a string of characters, string list one, okay? So we've stored a variety of things in the list. Now, if you want to reference specific elements of the list, you can do indexes, and lists are indexed from 0. So if you put 0 into list 1 and you use this exact notation and you press Shift Enter, it'll give you the first element, which is a 1. You can do list 1 of 1, which is going to give you the second element. List 1 of 1, which is going to give you the second element. And now what you can also do is you can do -1, okay? And if you put -1 in the index and you do Shift Enter, it's actually going to return the last element. Oh, why do I keep making this mistake? Okay, it's going to give you the last element, and this is probably a cool little way to introduce the concept of backward counting in Python. So if you do -2, it's going to return 5. So the way you want to think about it is the minus is relative to the 0th index. So when you do -1, it's 0, -1, comes around full circle, and it'll give you the last. And then -2 is going to give you 5, -3 will give you 3, and so on. So that's how the indexing system works. So that's all pretty cool. We've learned the basics of lists. So now we're going to make a little function that uses a list. And let's do some markdown. So write a function that returns the product of all elements in a list. Okay, so that's just going to be def prod of L. Okay, and we're going to make out equal to 1, and then we're going to write the loop for I in L. Out is equal to out times I. And now is a very good time to show you a nice little abbreviation. So remember how in the previous function we did out is equal to out times I. So similar thing when we were doing the factorial. What you can actually do is you can just do out this. Okay, so you do the asterisk and then you do equal. And that just means out it's a shorthand for out is equal to out times, and then whatever you want to multiply it by, which is just going to be I. And at the very end, you can return out, okay? But there's one little caveat that you want to handle, and that's if the list is empty. So you want to add a little condition right here that's going to say if the length of the list is equal to 0, you want to just return 0, okay? And if it returns, then it's not going to execute the rest of the code in the function. So that's pretty cool. And we can do prod of an empty list. Okay, and that's going to give us 0. We can do prod of 1. That should just give us prod of 1. That's just going to give us 1. And then we can do prod of 1, 2, 3, 4. Okay, pretty cool. So now we have our little function. We've gone over lists. Now the next data structure I'm going to go over are tuples. So I'll once again click Markdown. I'll add a little title, tuples. Okay, so I'm not going to go that into depth into tuples, but I'm just going to show you how to declare one. So a tuple is basically a finite set of elements. So unlike a list where you can just add elements indefinitely or arbitrarily to a list, a tuple is a way of defining a finite set of elements. So if we have 1, 2, okay, so we can make t1 equal to 1, 2 and shift enter, and then we can reference these elements, t1 of 0, t1 of 1, okay? And that's it. You can also do, I think, length of t1, right? So similar to lists, but you can't really add an element. So t1.append 4 doesn't work. Okay, so now we're going to move on to dictionaries. Now, dictionaries are very useful, and in terms of the native data structures in Python, you're most commonly going to be using lists or dictionaries. Both of them are incredibly useful. You're going to be using them if you are a professional developer. You're probably going to be using them just about every day on the job in some way or another. So what's so special about a dictionary? Well, I am going to show you. So let's create a dict. Ooh, that's taken, so I'm just going to call it D. And you want to use the curly braces to declare a dictionary. And in this case, we can declare an empty dictionary. And you can actually give, a dictionary is going to have two components, okay? It's going to have something called a key and something called a value. And here's how you do it, okay? Key 1, colon, and we can add a value, okay? Key 2, colon, and we can add any value. We can just say I am, you can just say me. You can put anything there, okay? And then we add another value. And then now, when you want to reference elements of a dictionary, you type key 1, okay? D of key 2, D of me. Okay, so this is pretty cool. So now we've gone over lists, we've gone over tuples, and we've gone over dictionaries. Now I'll show you a few more things for dictionaries. You can iterate through the set of keys for a dictionary. So that would just be ind dot keys, okay? D dot keys print I. And it's going to iterate through the set of keys in a dictionary. And you can also iterate in the set of values, so ind dot values and print I 157. Okay, so dictionaries are cool because you have two layers of abstraction. So with a list, you can reference elements by index. You can store them arbitrarily. Now, what if you want to add a new element to a dictionary? Well, that's not hard. You can just say D of new key equals 5. Okay, D of new key, and that returns 5. This is all some pretty cool stuff. And you know, now at this point, we've pretty much gone through all of the core concepts of programming. So we're going to devote the rest of this tutorial to solving a few nifty little problems and integrating the knowledge we've acquired thus far. Okay, so I have this problem prompt arranged for us, and it reads, given an integer array nums, Find the contiguous subarray containing at least one number which has the largest sum and return its sum. So what do they mean by a contiguous subarray? That just means a connected section in the subarray, and they want us to find the sum, the largest possible sum within any contiguous subsection of this array. And on the surface, this seems very intimidating. You might be thinking to yourself, okay, so do we have to iterate through all possible subsections of the array in order to find that? And the answer is no, we do not have to do that. And if you have development experience, I'll encourage you to try to solve this problem on your own. This is a very common problem that's presented in most first-year computer science university level courses. If you are brand new to programming, you're much better off just watching me walk you through the problem. Okay. So let's go ahead and solve this problem, and before we go into solving the problem, I'm going to give you a little explanation of the approach we are going to use. So the main idea is we are going to want to keep a running sum. And what does that mean? So we're going to have a variable called r, and I'm going to show you in text the steps that our algorithm is going to do before we write it into the code. So the idea is we'd have a running sum called r, okay? And in the very beginning, as we are iterating through this list, the running sum would be -2, okay? It's going to be -2 because that's the first element. So we add -2 to our running sum, which would start at 0. And then we go to the next element, okay? And running sum would be -2 plus 1, which is -1, okay? But then we would also be at the element 1. And what we would have to ask ourselves at this point is, look, are we better off just having the current element that we're already at, or are we better off having a previous sum, so a sum before us, and adding that? And in this case, we'd say, okay, wait a minute. If we have -2 included in the sum, we're actually worse off. We're better off not having that element inside and saying, you know what, screw having the -2, we're just going to have the 1. And then we'd go to -3, okay? And 1 minus 3 is going to be -2. And we're going to compare that to the current element, which would be -3. And we're going to say, you know what, we actually are better off having the 1 in there than just starting off at -3. And then we would go to 4, okay? And -3 plus 4 is 1, but then 4 is just 4. And we're going to say, you know what, we're actually worse off having the previous sum factored into our answer. So we're going to say, you know what, we're going to erase all the previous steps, and we're just going to start at 4, okay? And then we'd go to the next one, and we'd say, okay, the running sum is equal to 4 minus 1, that's 3. And then the current number is 1, and we'd say, you know what, we're actually better off keeping this sum along with the previous value. And then we would go on to 2. We'd add 2, right? So then 3 plus 2 is 5, and then 2, and we'd say, you know what, we're better off having the previous elements factored into the sum. And then we would go to the next element, which is a 1. 5 plus 1 is 6. And then we would say, you know what, we are better off keeping those previous elements in our sum. And then we would go to -5, okay? So running sum would be 6 minus 5, and 6 minus 5 is 1. And then the comparison would be to -5, and then we'd say, wait a minute, what just went on? Okay, we were at 6, and now we just went to -5. And the reason why that happened, that is a mistake in the algorithm, because what we also want to do is we want to keep track of a max, okay? We want to keep track of a max value, and our max value is the largest possible instance of our running sum recorded thus far. Okay, so if we now step back through it, in the very beginning, our max was -2. Then our max became 1. Then our max became -2. Then our max became 4. Then our max became, was still 4, okay? And let me go back. Our max, so our max was 1, our max was 1. Then our max became 4. Then our max was still 4. Then our max became 5. And then our max became 6. And when the running sum is lower, or when adding the next element to the running sum causes it to be lower than the max, we don't want to change the max value. So the max value is keeping track of the largest possible instance of the running sum observed so far. And at the very end, the max value would still be 6. And then once our algorithm terminates, we would return the value of 6. Okay, this sounds good. So now we're going to implement that in code, and it's going to be very, very simple. We are going to declare a variable running sum. We're going to make it equal to 0. We're going to declare a variable called max, and we're going to make it equal to the first element in the array. So that's a keyword, so we can make it maxi. Okay, we just call it maxi. And the next thing we're going to do, we can actually call it m for max, so r of 0. The next thing we're going to do is we're going to iterate through the array for I in r, and we're going to make running sum equal to the max. So this is a nice little function that's included in Python, which I will explain to you right now. So what max does is it just returns the maximum element that you give to it. So the max of 5, 2 is going to be 5. Okay. So then if a is equal to 5 and b is equal to 2, and you do max of a and b, it will output the integer value. Okay, so it takes in variables, takes in values, and it's going to output the integer value, which is the maximum. So running sum is going to be equal to the max of running sum. So running sum is all the previous elements plus our current element, or just our current element. And then we're going to say if running sum is greater than m, which is our max or maximum recorded running sum at any time, you want to set m equal to running sum. And then at the very end, we can just return m. So this should work. And if this works, the output should be 6. So max sum of, and we're just going to go ahead and copy and paste this list into the function prompt. We're going to do Shift Enter, and we get 6. So we can see that our algorithm is successfully able to iterate through the list and find the maximum possible contiguous sum in the subarray. Okay, so the next problem that we're going to be going over is the merge problem. We're going to be writing a function that takes two sorted lists of integers and outputs a final sorted list that combines the other two sorted lists. Okay, so if you have 1, 2, 3 and you have 2, 5, 6, it's going to output 1, 2, 2, 3, 5, 6. So it's going to it's going to combine them. And yeah, so let's jump right into it. Now, if you are an experienced developer, you should be able to do this problem in your sleep. But if you're new to coding, there's no shame in just watching me do it and learning that way. It's totally chill. All right, so we're going to define a function called merge. And it's going to take two lists, a left list and a right list. And then we are going to define some indices. Okay, we're going to have t. We're going to have t is equal to 0, and we're going to have a k is equal to 0. And it's important to note t is going to be the index that we use to iterate through the left list. K is going to be the index that we use to iterate through the right list. Now we are going to make a loop like we've done many times in this tutorial for I in range length of the left list plus the length of the right list. Okay, and now we're going to say if we reach the last element of L, okay? If we reached the last element of the left list and we have not reached the last element of the right list, we are going to, so we actually have to define our output. So this is going to be the final list that we are going to build up and then return at the end of the function. So back to what we were doing. So if we've reached the end of the left list, but we've not reached the end of the right list, we are going to add the current element of the right list to our output, and then we are going to move the right list iterator one step forward. Otherwise, if we've reached the last element of the right list and we have not reached the last element of the left list, we are going to add the left element, or the current element of the left list, and then we're going to move the iterator one step forward. Otherwise, if neither of those things have happened, so we've not reached the end of any list, what we're going to say is, okay, if the left element is less than the right element, we are going to add the left element. And then we are going to move the left iterator one step forward. Otherwise, so since we've covered all cases, we can just write else. We don't have to specify. But this else case basically means that the right element is going to be less than the left element. And we are going to append the right element and then move the right iterator one step forward. At the very end, we are going to return out. Okay. Now we are going to test the function, merge onto 1, 2, 3, and then 2, 5, 6. Okay, and now it returns the 1, 2, 2, 3, 5, 6, which is the correct output for merging these two lists. So this is a neat little algorithm. Go ahead if you can, if you want to take some extra time out and look through this function, experiment around with it, and really try to understand this, because this is probably on the more complicated side in comparison to the other problems we've solved so far in this tutorial. Now, the last problem that we are going to solve today is called the permutations problem. Okay, permutations problem. And the description of this problem is given a list of integers, output all the possible permutations of that list. Okay, so what does that mean? So let's say that we have the integers 1, 2, 3. Okay, well, all the permutations would be, you'd have the first permutation, which is 1, 2, 3. Then you'd have 2, 1, 3. Then you would have 2, 3, 1, okay? Then you would have 3, 2, 1. Then you would have 3, 1, 1, 2. And then, yeah, and then the last one would be 1, 3, 2, okay? So the last one would be 1, 3, 2. This is going to, I'm going to warn you, this is a harder problem to visualize. This is not going to come easily to you if you're new, but it's still a pretty compelling problem to solve. So, okay, so we're going to define a function called permutations. Or I guess we can just call it, permutations. And it's going to take an argument which is a list, so we can call it L for list. Then we can take another argument called start. Now, we're doing a nifty little thing, which is taking an argument and we're giving it a default value. So instead of like usual where you have to include a value for every argument that you give a function, in this case you can actually not do anything, and when we'd call the function we would just do permutations and then just do L, and it would automatically include a value of start equal to 0. Okay, so what we're going to do is we're going to say, okay, there's one more thing actually. We're going to have 3 arguments. We're going to have a list, we're going to have a starting value, but we're also going to have an output that we build up over time. Okay? So yeah, so we're going to say if the start is equal to the length of L, the length of the list, we are going to append, so we're going to do out.append the list. Okay, we're going to add the list to our final output. Otherwise, we are going to say for I in the range from start to length of L, we are going to perform a operation called swap. Okay, and we can do swap of I with the starting value, and then we are going to call the function permutations on L.copy. So we're going to copy the permutations. So we're going to swap the index of I with start, and we're going to perform that on the list that we have. So what we're going to be doing is we're going to swap the current element that we're at with the starting element, with the starting index that's passed in the function call. Okay. And then we would call the function recursively on a permutation of a copy of the list, then the output as it currently is, and then we would do start plus 1. So we'd take the element one step forward, and then we would swap I with start again on the list. So you're undoing the swap that you've just done. Okay. And all right, so we would have that, and then at the very end, you could return out. All right, so we're going to run that, and we can then test it out. Permutations of 1, 2, 3, and then we can pass an empty, because the output's going to start out as empty. Okay. Oh, it says swap is not defined. So we actually have to define the function swap. So swap is just going to take in a left index, a right index, and then it's going to take an array. And what we're going to do is we're going to say the array of L and the array of L and array of R is equal to array of R and array of L. So what that just does is this is saying that array of L is equal to array of R, and then array of R is equal to array of L. So it's kind of a shortcut coding trick. And now we are going to just return the array. So what swap is going to do is it's going to modify it's going to swap the elements on the left index and swap the elements with the right index. So let's do that. We have to include an S because we're calling a function. And there we go. Okay, so this function, it's going to take 1, 2, 3, then it's going to do 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 2, 1, 3, 1, 2. And then we can test it out on some larger lists. So 1, 2, 3, 4. And there you go. You can see that it's going to print out all the permutations 1, 2, 3, 4, 1, 2, 4, 3, 1, 3, 2, 4, 1, 3, 4, 2. It's going to go through all of them. If you want to get really crazy, you can do 5, 6, and this is going to be a lot. Yeah, it's going to be a lot of permutations. If you've studied math, you know that the permutations of a set grows with factorial complexity. So the complexity of this algorithm would grow pretty quickly. So that's going to be it for today. This was an introductory tutorial for Python. We covered an impressive amount of ground. We did printing text, we did some arithmetic, we did Boolean values, we did Boolean operators on numbers, we went through control flow, we solved some recursive problems, we wrote some recursive algorithms, we wrote a factorial problem, we went through all the basic data structures in Python, and then we wrote some pretty cool algorithms, especially for beginner coders. These are pretty cool problems to solve as a newbie. So that's going to be it for today. I think that if you've watched this, you have the foundations to go out and learn more. I'm not a particular fan of buying online courses. I'd say if you want to learn more, get a book. And in particular, try to find an open source code base and just go on there and try to understand what's going on. And anything you don't understand, you can just reference the Python documentation. Okay, so you can just search Python documentation, and there you go. Right, you can find the documentation, which is the all the information you need to know about writing code in Python. So that'll be it for today, guys. Thank you so much for watching. Be sure to like, comment, share, subscribe, all that good stuff. See you guys later.